In 2009, the University of Miami College of Engineering commemorated the 50th anniversary of our longtime home, the J. Neville MacArthur Engineering Building. The purpose of this video is to recognize the buildings or homes that the College of Engineering has occupied since its founding in 1947, or hope to occupy in the near future. Join us, therefore, in our tribute to the MacArthur family as we honor their generosity and as we detail our aspirations for the future.
Founded in 1947, which was some 21 years after the founding of the university itself, the School of Engineering first occupied the Anastasia Building. Thus, the Anastasia Building was the College of Engineering's first home. The university leased the building and quickly installed room dividers to make the building function as a school. Thus, the building earned its nickname, the Cardboard College. In 1959, thanks to a generous $1.1 million donation by James Neville MacArthur, founder of the MacArthur Dairy, the College of Engineering was relocated to where it is today. At the time, MacArthur's contribution was the largest individual gift in the university's history. But MacArthur's generosity didn't stop at the completion of the building. Giving an additional $100,000, he then equipped the structure to meet all of its educational needs. In 1961, the Miami Herald recognized MacArthur's philanthropy, describing him as a distinguished gentleman and civic leader. In the article, MacArthur commented about his contribution of a building for the College of Engineering. "I owed it to the community," he said, "and as long as I live, I am going to contribute to its welfare." It should be noted that the MacArthur legacy of support to engineering continued in 1989, when daughter Jean MacArthur Davis contributed over $3 million to build the 19,000-square-foot annex, also the largest gift to the University of Miami at that time.
Here at the College of Engineering, University of Miami, our research is really subdivided into three main categories. The first of those topic areas is technobiology, which is the application of engineering to biology.
What we're trying to do here is truly spectacular. We are building the bionic human, and what we're essentially trying to do is merge together engineering principles with life science principles to really restore ability to people that have been disabled in terms of spinal cord injury or traumatic brain injury and things of that nature. And to really do that, we need truly remarkable facilities to do wet lab kind of research, again, implanting devices into living organisms, extracting that information from those organisms, and then really interfacing them with engineered kinds of prosthetic devices.
Other area of research that we have includes sustainability. And the sustainability aspect focuses on how do we design systems so that they will be here for a long period of time.
One of the most exciting applications of composites nowadays is the jacketing of columns. Columns that have been designed with old building codes are susceptible to fail during, for example, a seismic event. So we can strengthen from the outside by providing composite jackets. And in particular, we have tested beams, reinforced concrete beams, that are strengthened with carbon fiber reinforced polymers.
The third area of research includes informatics and risk.
In computational fluid dynamics, we're interested in turbulence, which is an unresolved problem in physics. So we developed some very advanced numerical algorithms. Eventually, if we can really resolve this turbulence very well, and then we can save a lot of testing, like wind tunnel testing. Wind tunnel testing is very expensive because computing is relatively easier to set up than experiment.
Nanotechnology is now poised to change the very nature of computing, healthcare, energy, and transportation, among other areas. Irrespective of discipline, our recently hired faculty are all well versed in the potential of nanotechnology. Fortunately, they will soon have the ability to work in a nanotechnology clean room, which is being constructed at the recently built Life Science and Technology Park. Clearly, nanotechnology is a field in which we, the College of Engineering, must promptly establish our renown. Coincident with the 50th anniversary of the MacArthur Building, the College of Engineering has been given a new mandate. We are working with our 10 sister schools and colleges at the University of Miami to help achieve the status of a preeminent research university, thus joining an elite group of institutions known as the AAU, Association of American Universities. In order to reach AAU recognition, the College of Engineering must broaden the scope and achieve critical mass. especially in the range of engineering disciplines that comprise a first-rate engineering enterprise. To complement our current 120,000 gross square foot MacArthur building, we propose to construct a 90,000 gross square foot engineering innovation complex. Such a structure has already been identified in the University of Miami's master plan as being located in the north side of the existing MacArthur building. The proposed engineering innovation complex should be able to accommodate the college's expected growth in the next decade, from 750 undergraduate students to 900, from 150 graduate students to 400, from $3 million in annual research expenditures to $30 million, and from 60 tenure-track faculty to 100.
Within the proposed new 90,000 gross or 60,000 net square foot state-of-the-art structure will be a 10,000 square foot, 300-seat multi-purpose collaboratorium for presentations and collaborative interactions with compatible venues, both within and outside of the university. A 6,000 square foot multidisciplinary design and innovation center, where students, faculty, and industry partners can work together on their various hands-on projects. A 5,000 square foot nanotechnology clean room, outfitted with modern etching and lithography equipment for research and educational purposes. A 3,000 square foot data fusion and visualization cave with links to an expanded College of Engineering cloud of servers that could integrate terabytes of data for both analytical and visual analysis. A 3,000 square foot prototyping machine shop that can provide the faculty with a competitive advantage in their proposed research efforts, as well as serve the South Florida community of innovators. And of course, additional offices, teaching spaces, and research laboratories. The Engineering Innovation Complex itself will serve as a living laboratory for research into green construction technologies. Indeed, an overarching goal of the new structure is to become a self-sustaining building with a net zero consumption of energy and water.
Basing the Engineering Innovation Complex on new green technologies, we are indeed going back to the future, consistent with the MacArthur heritage of employing the most advanced building technologies when the MacArthur Engineering Building itself was being constructed in 1959. Academic buildings such as the Anastasia Building, the J. Neville MacArthur Engineering Building, and the proposed Engineering Innovation Complex are essential for nurturing critical thinking, thoughtful learning, intellectual discovery, ideological exchange, social engagement, all activities that underpin a preeminent institution of higher learning. As we educate tomorrow's technology leaders for career success, please help us to make the Engineering Innovation Complex a reality so that it may become a vital and integral part of our college and the University of Miami. As we conclude this video, I thank you for allowing us to share with you our proud heritage, made possible by the MacArthur family, and our critical need for an Engineering Innovation Complex.